Okay, so the first question that we wanted to look at is 2.5M, this big, long monstrosity of a compound here. And anyhow, you can start by tallying up the number of carbons, maybe. I don't know. There's a bunch of different ways you could approach this. But what I'm going to do is I'm going to start with this methine here. So if you remember, when we have a CH3 group, we call that a methyl. When we have a CH2 group, we call that a methylene. And when we have a CH by itself, we call that a methine, I-N-E, methine. So I'm going to start with this methine that I have in the red box. And I'm just going to put a dot here. Okay, so that's for that carbon. And then it has two methyl groups coming off of it, like this. So I'm going to put 1, 2 methyl groups coming off of that methine. And then it's connected to another methine. So I'm going to put that in black. So it's connected to this methine here. And then it has a methyl group attached to it, but that's in a bracket. So that's going to branch off like this. And then this methine is also connected to this methine, okay, the one that I have in the green box. So I'm going to draw another line to another methine. Okay, so this one here with the star on it is this methine here, which has another methyl group attached to it. So I'm going to put this one in a red box. So I'm going to have another methyl group attached like this. I'm just going to put it down. And then you might be confused by this part here, which is CO2. So that denotes that you have an ester functional group. So you're going to have a carbon and then 2 oxygens. One of them is going to have a double bond, and then the other one is going to have a single bond. So that's our ester. And then the very end, we have CH2, CH2, CH3. So we go CH2, CH2, CH3. And that is the bond line structure of the compound. So if I take this and if I copy it, come on, copy, and then I paste it down here, okay, and if we put it all in one color, okay, this is the bond line structure of the compound. It's not drawn the prettiest way that I have it here. There's nothing wrong with what I've done, but you might want to count or look at the longest chain, which goes 1, 2, 3, 4, 5, 6, 7, 8, 9 atoms like this. So you could go 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. And then you're going to have your oxygen here, and then something like this, and then you've got a methyl group here and a methyl group here. Let me just clean this up a little bit here. We have our oxygen here. And so that's another way to represent it. They all mean the exact same thing. But to the student who asked me the question, Savannah, does that help a little bit? I'm assuming that one of the areas of confusion might have been the functional group, the ester that was in there. Okay. All right. I think that the way you have it written is exactly the way I wrote it. It's so if I look very carefully, you have CH3, and there's 2 of those. Then you have a methine. Then you have, they have the methyl, so they have this methyl before the methine here, but that's totally fine. And then they have another methine with a methyl, and then they have CO2, and then they have the propyl group on the end. No, there's nothing wrong with the way that I have it. They're not, no, 1, 2. Did I copy it down wrong? Could that be? Let me go back here. So 2.5 M. 2, 3. No, it's not. I think you're wrong because I'm counting 1, 2, 3 methines in the question, right? If you look at the question in the 4th edition of Klein, and we're both looking at the same edition of the book, right? You see it here. So you can see that I have it. Yeah. So are you using the electronic textbook? Yeah, you're using a different version of the textbook. That script looks different to me. That you have it. Okay, yeah. If you're not using the so I would use the electronic version of the textbook because I'm not aware of there being a PDF of the 4th edition. So this looks like a different edition of the textbook. So if it's a different edition of the textbook, then it won't align with the solutions manual. So I'd be very, very careful about that. All right, well, let's move on. And let's take a look at question 2.52. And we're asked to draw some resonance structures. The name of this molecule, I'll just, every once in a while, I'll give you the name of a molecule. This is called aniline. Aniline. All right. Anyhow, the name is neither here nor there. But if you look at the structure of aniline, the first thing that I notice is that we have an allylic lone pair. Okay, so we can start by drawing some curved arrows where we make a pi bond. And of course, we'd have to break this pi bond. And that's going to give us a 6-membered ring. We're going to have a lone pair here, so we'll have a negative charge on this carbon. And now the nitrogen is going to have 4 bonds and no lone pair, so it has a positive charge on it. Now we have a new allylic lone pair, and so we can move that charge. So we'll move the charge here. We'll make a pi bond like that, and then we're going to put a lone pair down here. So we're going to end up with something that looks like this. It's just the same old thing, rinse and repeat, right? Same old thing. I'm going to condense this from having both bonds shown here to just put NH2, and I'll put a positive charge here. And then we have another allylic lone pair, so we can keep doing the same thing. And we'll push the arrows here. We'll make a pi bond, and we'll put the lone pair up here. And we end up with the last resonance structure, which is going to look like this, where we have NH2 plus, and we have the negative charge here. Of course, you can draw another resonance form, but that's going to take you right back to the beginning. If you make a pi bond here and put the lone pair up here, that takes you right back here. All right, so nothing really new there. And so there you go. We've drawn all the resonance forms of aniline. Let's try 2 more. So this is C. Let's go all the way down to B. Does anybody? Oh, it's Pablo. Pablo, you're there. You recognize any of the patterns here? Or anybody? Maybe Pablo can't hear me. I don't know. Anybody recognize any of the patterns here? What pattern do we see here in 2.52? Or if anybody could tell me, like, where do I start? And don't hesitate to unmute your mic if you want to do it that way. Yeah, there's conjugated pi bonds. Yeah, so there's conjugation for sure. So we can use that to our advantage. Yeah. But where would I start? There's a lone pair next to a double bond, right? We have an allylic lone pair. Okay, so we'll start with that. We have an allylic lone pair right here. And so we're going to start by making a pi bond. Then that would make a Texas carbon. So we have to put a pair of electrons over here. So let's draw the next resonance form. And so we're going to draw our 6-membered ring. We didn't do anything to it. We didn't do anything to this. Now we have a pi bond out on the end, and we have a pair of electrons here. So we have a negative charge. We have a carbanion. And now we have a new allylic lone pair. So let's just keep going. Move this gravy train right along here. So we're going to put this pair here to make a pi bond, and then we're going to break this pair and put a pair of electrons down here. So again, we don't change the 6-membered ring in any way. And now we have a pair of electrons here. Oops. There we go. And we're going to have a pi bond here. And then we have a pi bond here on the end. And then we're going to draw another resonance form because we have another allylic lone pair right here. So let me just zoom in here. We'll take this and we're going to make a pi bond here, and we'll put this pair of electrons out like this. And there you have it, my friends. That is the last resonance structure we are going to draw for this guy. There we go. And so we'll just close the bracket. I don't know, where would we close it, I guess. Here maybe, something like that. But there you go. Those are all the resonance forms. Maybe here. There we go. All right, so there are all the resonance forms of this guy. Let's try one more. This is another common compound. This compound is called acetophenone. Yeah, so could anybody give me an inkling? Where would I start here? One of the patterns that we haven't talked about a lot today, if at all, is we're going to see that in this compound. Where would I start? Like, how can I start by drawing resonance forms here? Yes, there you go. No, I can't do that. I can't take a lone pair from the oxygen. But do you notice that we have a pi bond between two atoms of differing electronegativity? That's the pattern, right? Because we have a carbon. We have a carbon and an oxygen. Carbon is more electronegative, right? So we're going to be able to move these electrons from the pi bond onto the oxygen because it's more electronegative. And that's going to give us something that looks like this. So now we're going to have a single bond here, and we're going to have a negative charge on the oxygen, and we've got a positive charge on the carbon. All right, we've produced a carbocation, and now we still have all of our pi bonds. So now we have an allylic carbocation, and that kind of sets us off, or starts us off on our way to drawing all the resonance forms. So with our allylic carbocation, we can first stabilize the positive charge by moving these pi electrons. That's going to give us this. So where we have our negative charge on our oxygen still. And now we have a positive charge on this carbon. Do we have a new allylic carbocation? The answer is absolutely we do right here. So we can move these electrons. We can move these electrons over here. And if we put these down like this, we're going to end up with something that looks like this. So we have a negative charge on our oxygen. We have a positive charge here. Then can we draw another resonance structure? Yes or no? Could anybody answer that? Can we draw one more resonance structure here? Could we draw another one? Absolutely, right? Yeah, just give me a minute, okay? Okay. Because we have an allylic carbocation, and so we can draw another resonance form here. We're going to make a new pi bond like this. And we're going to move those electrons here to make a new pi bond. Here's our carbocation. And there's the negative charge on our oxygen. And we're done. We've drawn everything. Now, if you're wondering, well, couldn't I, draw another form to stabilize this? Could I say, well, I make my pi bond and then restabilize this? Yes, that will take you right back to the beginning, though. So let me just draw that one in here. That would take you right back from whence you came, kind of thing. But there you go. Those are all the resonance forms of acetophenone. All right, and there we have it. Yay!